Welcome to aminacademy.com. In Geometry Challenge, can you find the area of the green circle here? Here, a square ABCD is given, which side is 64. Now, this quarter circle, that is BCD, and semicircle and this full circle touch each other, having common tangents. Now we have to find this area of this shaded circle. For that, we have to join first center E and corner C. Now let it be, this is the radius of the semicircle is capital R, and this radius of the quarter circle must be 64. Because it's the side of the square is given, a quarter circle is 64. Now in triangle, BCE, this triangle BCE, then by using Pythagoras, because it is 90 degree, 64 plus R, the whole square, equal 64 square plus BE is 64 minus R, because this also R, total is 64, AB is 64 and here R, so 64 minus R the square. Expanding this, 4096 plus 2AB 128 R plus R squared equal 4096 2AB minus 2AB 4096, and another 64 minus R whole squared is 4096 minus 128 R plus R squared. Then here R squared cut, and 4096 cut. The remaining things, 128R minus plus come this side is 128R plus 128R equal 4096. 256R equal 4096. Therefore R equal 4096 over 256, which is equal 16. So we got the radius of the semicircle R is 16. Now in triangle FGE, here we know that this, let it be this smaller case, or radius of small circle is radius R. Then here you can see this also R. and extend here. This, let it be G. Now triangle FGE, join here also. That the center of the circle is F. Triangle FGE and triangle FGE. Look at here. This is also using Pythagoras because this at G is 90 degree. So EF square, that is FE square, equal FG square plus GE square. Here FE square, look at here, FE is smaller capital R plus small r here because EF is together R plus R plus R the square equal FG. Let it be FG is X here, X square plus G equal R minus R, capital R minus small r here. R minus R whole square, expanding both sides, A plus B whole square, R square plus 2RR plus R square equal X square. A minus B whole square is R square minus 2RR plus R square. Both smaller case R square cut, capital R square is cut. So we have X square equal 4RR. Now therefore X equal square root of 4RR, which is equal square root of 4, or we got 16 small r, which is equal, therefore X equal 4 into 16 is 64, square root of 61 is 8 square root of R. So we got X value 8 square root of R. This is X here. Now let it be this F2, let it is H, is equal to Y. Now in triangle FCH, this triangle also join. In triangle FCH, this 90 degree here. In triangle FCH, FC square by Pythagoras equal FH square plus HC square. FC square, look at here, FC square is R plus R whole square, capital R plus small r whole square. (64) plus R whole square equal FH is 64 minus X square plus HC. HC equal to, we let it is Y. FH equal to here. Fh is y square plus hc equal 64 minus r square. Fh y square and this both we can express now. Expanding both sides, 4096, that is 64 whole square, plus 2ab 128r plus r square equal y square plus 64 whole square is 4096 minus 128r plus r square. So both sides this cut, r square also cut. So y square equal 128 plus 128 is 256r. Then y equal square root of 256r, which is equal 256 square root is 16 square root of r. We have x and y values. So x equal to 8 plus r, y equal 16 square root of r. Look here in figure, x plus y is equal to side of the square, so it is equal 64. So we can write gh equal gf plus fh, which is equal x plus y. Therefore 64 equal x plus y, which is equal 8 square root of r plus 16 square root of r. Therefore we can say 16 plus 8 is 24 square root of r equal 64. Square root of r is 64 over 24, which is equal 8 over 3. 8 over 3. Now square root of r is 8 over 3. Then r is squaring both sides, 64 over 64 over 9. The r we got it, that is the radius of the circle. R is 64. Then area of the shaded circle equal pi r square, which is equal pi into 64 over 9 the square. We can say it is 64 square is 4096 over 81 by square unit. We have done. Please subscribe our YouTube channel.